Yeah. Shield, you mean? Yeah. But
I don't get to start my clinical until next Tuesday.
How come?
Because I have to do my fit mask thing.
Oh no! Why do they need a? Why do you need a fit mask for that hospital?
I guess county people can be contagious.
Oh,
I don't know.
Yeah, I can see that.
It's okay. You guys can have fun without me.
That's like the place to be. That's where you're gonna get most of the experience.
Really?
Yeah, for sure.
After looking around the VX.
Does everyone have a chance to look at the practice exam?
yes.
Did anyone not get a copy of it?
Oh, we got a copy of it, but we have a few questions on it.
Of course.
Number.
Anyone need a copy? Sure. You want a copy of it?
Got a copy of it and the plans on the paper sheet.
I have this calculator since freshman year of high school.
What?
That was when I was totally into the vegetarian PETA thing phase.
Cute.
This thing is a workhorse.
Have you changed the batteries in it?
No. Yes. You guys have the newer version of this.
Yeah,
It's
it's nice and simple. I love it.
It is. And it has all the functions that you need.
What's the verdict?
So soda's not sealed. Totally had a face.
Any verdict, any opinions?
Seems reasonable.
Seems reasonable.
How many questions on the exam?
Should it be similar to this?
What?
About the same range. Maybe one or two more, maybe one less, something like that.
I'm so happy I'm not camping because I feel like comfortable because
Professor?
seriously.
Also noticed that, but like for number 4,
Like I actually got through them and I felt pretty good. I was like, oh my god! I was like, I know this. Like I know this one. But two of them, I'm just like,
So you better have them on yours.
Yeah.
Seriously. Second look, I'm like, oh. So I feel like personally, I got to the point like many years ago. Like when I don't do anything with it, or anything, like, I've had it. And it's just like where people thought I was like, I could like throw my little thing here, and now I'm just like clean cut.
Are we gonna go over this practical thing? Or practice thing?
I think so.
Alright, so all the solutions, almost all the solutions have been put up by your classmates. Only 6 and 8. Well, last time I looked, I haven't looked this morning. 6 is up there. But I think 8 is the one that's causing actually most of the grief. So we'll skip right down to 8. So skip over to number 8. That's the one that caused most of the grief. And it seems just so straightforward enough. There has to be a trick to it, right? When t is 40, what is y?
1.9?
Something close to that. You said t is 40, so you're just reading up here. And if you said 2, that would be fine. 2 is the correct answer to that. Then, okay, part B, I just asked you to turn it around. When y is 2, what is t? And you put down, okay, you put down 40 because you just answered the question above, and you can flip things around in your mind. And that's the mistake I didn't want you to make. You have to go back and look at the graph. Because what you want to do, y is 2, you start here, and you hit the graph. Sure enough, you hit it there, but you also hit it over here. There's more than one value.
Sneaky. That was a good one.
Oh, there's another value. Whatever that is, let's call that 68. Yeah, and that was about as tricky as it got. The next one, part C, was slightly tricky. But I think most people would have figured that one out. Y is 20, when T is 22, we'll put that about here. And we'll draw a line up to about there. And that's really not clear where it's coming in. So we'll put it somewhere like here, approximately there. So now it's just a matter of figuring out what that number is. So you count up and you say 0.2, 0.3, 0.4, 0.5. It's bigger than 0.5 and less than 0.6.
0.55.
So 0.55 would work for me.
Oh, darn it.
Good job, Dennis.
Thanks.
Yes.
Yeah. So, any leftover questions on graph reading?
But on the test, if we put 0.5, it's right, and if it's 0.6, it's right.
I would give you credit for 0.5 or 0.6,
Okay.
sure.
Good, thank you.
Well, we still.
Not 0.45 though, but something between 0.5 and 0.6 I'd be happy with.
Will we still get credit if we missed the 68?
Yeah, you get some partial credit.
Thanks.
Yeah, no.
That was a good
The
one.
other one was correct, it was just incomplete.
Oh, I don't have it.
Without the 68 there, the answer is incomplete.
Yes, okay, so the one is 0.5.
So you're clear that there's two types of graphs. Well, there's linear graph scales, linear and log, and you know how to read them. Is this a log linear, linear log, or log log, or linear linear?
So we have to look at the lines in there to tell about that, the little lines.
Well, how does it fit into your categorization of linear, log, log, linear, 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 log, log?
Linear log.
To be clear, it's just spell it out. Log, the vertical axis is blank. The horizontal axis is blank. Don't have to worry about the exact order of them, but you would know how to spell it out. So just spell it out and say, vertical axis is log, horizontal axis is linear. Seven was a long question, but that kind of sums up the whole mechanics section. What did we miss in this one? Did we miss anything?
This is linear, but this is pound
Longish? Is there anything from the mechanics section that didn't show up? Yes.
I have a question on part C.
Part C of on this one.
Yeah. Is it negative point
number?
0.88 or positive 0.5?
How far did it
Or
move?
0.5.
It's a positive distance. How far did it move? Because it starts at rest and accelerates for a time, so you should have come up with a positive distance. See, about the only things we missed with the mechanics are
Momentum.
momentum. So just make a note of what's not in here is momentum. It could show up on the test. Anything else that you did in mechanics that was not obviously here? Always when you do a practice test, you want to make sure you look for what's not there, because practice tests are kind of random samples of what might be there, so you always have to look around the edges and see what's missing. Anything else that's missing from mechanics?
In regards to the getting answers that are positive or negative, sometimes you disregard it, correct?
Sometimes you disregard it.
And then, is there a rule of thumb? Like
Rule of
when
thumb,
you
when the
do and
word
when you
magnitude comes up, you disregard the sign.
don't?
If the word magnitude is not there, then the sign is usually of some importance.
Okay.
If there is a sign, then what you should try to do is see if you can come up with a physical interpretation of what that sign might mean. Like, what do you put down for gravity?
Gravity is
9.8 meters per second.
squared.
Gravity is 9.8 meters per second squared.
Yeah.
Is there a direction to it?
Down.
Down.
Now,
So you can do one of two things. You can either put a negative sign on it, or you can just say, put the word downward. And sometimes if you're looking at a negative sign, it means downward. So you could either do the negative sign, or you could say I'm not picky on which one, but if you do have a problem with a negative sign, either try to be careful with it or try to come up with an interpretation for it. I'll take words as symbols as well. Yeah.
I can determine the height dropped as the zero change in distance. As it dropped, you could register as a change in distance.
Well, exactly that.
Like you could say that the 100 height is your starting point, which is 0, and the change of your distance is wherever it is at a certain time, a positive number, and you can make your acceleration 9.8.
Well, okay, so you're going to start here.
Yeah.
And you know that this is 100 meters.
Yeah.
You're going to end here. And somewhere along the line, you kind of have to decide on a coordinate system. And that's where the minus signs tend to come into play. Typically, most people are happy with up as positive. So we're going to take this as the positive y direction. And we're going to take this as y is equal to 0, and we would take this as y equal to 100. Would be the most common way to set that up.
Yeah, I did it the other way.
It's fine if you did it the other way. And in this case, numbers increase as going up. And so we would want to indicate that gravity is pointing down by having that negative 9.8.
Okay.
So in this case, since the numbers are positive going up, we would write gravity as negative 9.8 meters per second squared.
And in C, on this particular question, if you put negative 0.588, how would you just interpret it that it fell to the earth?
Well, let's see what the problem says. The object accelerates with a mass of 37.5 micrograms, accelerates from rest. So it doesn't say anything whether it's horizontal or vertical, nothing about that. Doesn't say that there's even gravity in the picture. But you have an acceleration there, which is not gravity, so you're pretty sure that gravity's not in the picture. So you might want to just say, okay, it's going to start here at x equals 0, x initial equals 0, and then it's going to start with v initial equal to 0. And we have the acceleration, so you're going to say that x final is equal to x initial plus v initial times t plus at squared over 2. It turns out that these are all 0. We don't care about them. So this is just acceleration 1500. Now you got to deal with those units correctly, right? Milliseconds, you would correctly interpret it as 28 times 10 to the minus 3. You have to square it. You have to divide by 2 when you get your answer. Was it something like 0.588?
Mm-hmm.
Was it?
I got 42.
How far did it move?
0.588.
So we got, how far did it move in that time? This is 0.588 meters.
Okay, so then you don't have to do the
Oh, okay. We're on B right
change
now?
in.
Oh, no, we're on C.
Oh, okay. I got that right. Never mind.
You don't have to do a
Well, you-
distance final
I
minus.
use a different formula.
It depends, it does, we don't have any information about where it started from, so we said, I guess
Yeah,
let's
yeah,
set
square.
x
Yeah.
initial equal to 0. You get the same answer if you set this equal to delta x, which is equal to x final minus x initial, which will also turn out to be at squared over 2, so you'll get the same answer.
Okay.
Okay, what about that final speed? AT.
Yeah.
Because it starts from rest, we do know that.
The formula's in green.
42. And I should emphasize that units are important in your final answers. You will definitely lose points if you don't have units. Unless units are not present to begin with. Anyone have trouble getting the force on that object? What was the trick in getting the force?
Is mass times acceleration to get the force.
That's not the trick. What's the trick? I made it slightly tricky. I want the force in newtons.
Newtons, yeah.
So if I want the force in newtons, how are you going to get it?
Micrograms and kilograms.
Kilograms.
You've got to convert the micrograms into kilograms.
Yeah.
Yes, definitely. Someplace on the test, I'm going to make sure that I try to throw one at you where you have to get things from something into something into some other set of units.
37.5 times 10 to the negative ninth power kilograms.
37.5 times 10 to the negative 9 kilograms would do it, yes. Then you've got everything in SI units. And we got 5.63 times 10 to the minus 5 newtons.
Yeah.
Again, units are important. Any other leftover concerns? That's about the trickiest part of it. What about D and E? Just why are they so closely connected to each other?
Because work is the amount of work you do is the same as the change in kinetic energy.
Right. So that actually gives you two different ways to calculate this. You can either calculate the change in kinetic energy and say that's the same thing as the work, or you can calculate the work and say that's the same thing as the change in kinetic energy.
So as long as you acknowledge it, it's okay to
Yeah. Just say they have to be the same. Exactly. And of course, power was just work divided by time, so there was no tricks there. All right, we didn't have any potential energy in this. That was the other thing that was missing from this set. So in addition to momentum, there might be a question involving potential energy.
Which is mass times gravity times height.
Yes, it would be gravitational potential energy. All right. 6. I think 6 intimidated people for quite a while. Until you saw it and you said, aha! Why is that so simple?
Because the velocity of this photon is like the same as speed of light, which is 3 times 10 to the 8 meters per second.
All photons.
Yeah.
Yes, all photons. That's what I was looking for, that you recognized what that photon was. All photons have the same speed. Energetic photons and lazy photons, they all go at the same speed. Okay. So once you know that they all go at that one speed, there's only one speed involved. Distance is equal to speed times time. And there's one other thing about photons, didn't say it, but might dawn on your mind, or across your mind, that photons don't accelerate. They just have one speed. They go, they're born moving at that speed and they die moving at that speed. They don't ramp up to anything.
They don't have any mass.
They don't have any mass, exactly.
So when one realizes that photons don't have mass, they realize speed is constant and they move at the same speed as light.
They move at the speed of light. They are light.
Mm-hmm.
Yeah. Oh,
Okay. So
Unless they hit that.
unless they hit something. Then they get absorbed. Okay, 5. Just be aware that, exponential equations might show up. This one, yes, was.
I'm sorry. So how do we answer number 6 then?
Oh, distance times time. So that is 3 times 10 to the 8 meters per second times 1.25 times 10 to the minus 9 seconds. Second goes away. What do we get?
3.75.
0.375 meters.
0.375 meters.
So that's correct.
And again, the units are there. So there's 3 particles which you have to be comfortable with. Which 3 particles?
Yeah.
Not necessarily for this problem, but sort of in general. Expecting you to be able to identify the properties of 3 particles in particular.
Proton, electron, and a photon.
Electrons, protons, and photons. We'll leave the neutron for next chapter.
Now, protons, the mass will change. Won't it? Or is it always constant?
Their mass is constant.
The mass is constant, okay.
Okay, exponential equations. This one is plugging in, finding in. You, of course, are comfortable going the other way. Given an n, find a t. Take that as a yes. How tricky was this one?
Just need to convert the Celsius to Kelvin and then compare that with the final temperature.
Yeah, it wasn't terribly tricky.
Just need to make sure I put that.
Make
put
sure
that
you have
conversions.
the temperature conversion on your formula sheet.
Do we need to know neutron mass since it's on the practice exam?
Not until next chapter. Or we didn't use it anywhere.
Okay.
And what about these proportionalities? At this point, those proportionalities should not have seemed like any major problem. You can check your answers against those of your classmates who have put them up.